Okay, Octagon set Ventures in 3D printing through January now, 2023. So this is a tank valve, various attempts to actually make one. So we have pretty much 3 generations of hardware, 1, 2, and 3. Effectively, you push a stock, which is these 2 guys, inside, which would be up inside these 3 sleeves in the back, and then the little tip here pushes a ball, which is then spring released by this. Now, this washer over here, or flange, actually locks in. If I push it down and overextend it, you can see how it kind of locks into a bit of a groove. So first I printed this one, which was fine, except for this was too short. Then I printed that one with a little notch long enough, but then it broke off because it's not as solid, so I have to change the design. And here you can see I have a small ball. If we can look under here, we can see we have a medium-sized ball, same size ball on that side. So I'm just going to go through all the various hardware generations. So effectively what happens is in any generation you actually push this through. This actually seats at the bottom of the valve. I'll grab the latest generation one because things don't fall apart. You can see it actually slots in here, and you can see the ball is actually covering the bottom. So, and like I said, the little nipple or the little pin at the end there actually pushes the ball. I'll show a demo a little bit at the end of the video. So what ended up happening with the first generation is that the top part was too rinky-dink. The ball was too small. Primarily the cage that is actually around the ball, you can't even see it. It just broke off completely. And then the idea is you actually want to push the little plate here with the holes in it through the cage. You can see all the little various holes, but the individual stalks were actually too small. So then we go to generation 2, where again I made everything a little bit bigger. But again, if we turn around and we look at what happened with the printing, you can see only one of the little stalks actually survived, kind of in whatever form, and the whole arm piece to actually hold on to everything fell apart completely. So I'll just keep that back there. So this is generation 3, and we can actually see the mechanism actually works. So this is going to be a bit hard for me to show with the cell phone in my hand, but effectively what ends up happening is that the needle pushes, I'll do it this way, the needle pushes the, actually we'll just do a full demo. The needle pushes the ball down, so as I push this through, you can see the ball comes down, and then you can see the plate actually bounces everything back up. And if we flip this back around, reasonably happy with what's going on there, except for 1, 2, 3, 4 of these things that belong up there actually broke off. So now I got a design iteration number 4 where everything is a little bit beefier. So assembling this thing, I'll use the first example over here. So I've actually got the spring set in at the bottom, and what we have is we put in the key slot sleeve over top, which is fine. Then after that we push this guy over here and we push this in. If I push this down, it'll release. Okay, so the goal now is to basically, with this gear that is over here, is to basically actuate it using a button, which I'm accessing over here. So in order to do that, I have a number of parts over here. First is this piece over here, which is the actual button that we push. And what we do is we seat it on a sleeve over here. Oops, wrong side. Seat it down over here, and as the button is pushed, those racks actually displace. And they turn these gears, which turn these angled rods, which turn this gear, which sits in the back and rubs up against the angle piece. Okay, so let's put this together, and here we have the overall seats. So interestingly enough, this is the first attempt at making the button. Everything was badly made and too small or too thin, so it actually fell apart. So here we have the seats. So we've got these two gears sit on either side. We got the angle gears that sit down in here, and then we have this back gear that sits over here. Everything is made with 2 millimeters. I find is the smallest size before things start to break. So this, and I use a 0.4 millimeter tolerance. So basically, the slots here are 2.8. And basically after 2 millimeters broke, I tried increasing just the size of the shafts and the flanges that are at the end, these little edge pieces. So I went from 2 to 2.2 and 2.4. I think I went from 2 to 2.4 to 2.6, because these were definitely 2.6. As you can see here, this broke right out of the printer. This other one broke, so I just chucked it. And effectively, if I look at how this would, this is the bottom and this is the top, right? So if I set this over here, kind of explains how that works. So I'm going to put this together now, which is a little bit delicate. So I'm going to stand my camera up over here. So effectively what I'll do is I'll take the seat and I'll grab these two pieces. So I'll wrap it around the key slot, and I'm going to hold it in place. And I'm going to grab the biggest diameter ones I have, stick that in there. Then take the angle rods and put them in. Angle rod number 1, angle rod number 2, and then these little guys over here, 3 and 4. And then this little guy over here sits down over top, forming a nice little package. And over here we have, there's these little slots, little holes that come and wrap around all the way to the key slot. And in here I have the springs. And that makes sure that the button will actually bounce back. So if I put the button over the top here, that'll slide in under the gears as I showed before. And if I can get this guy to behave. Now, I don't know how well you can see. This gear definitely turns quite well, but the angle gears are not engaging because they're too small. And it's a question of tolerances with 3D printing. But when I grab this overall and I stick it in here, you can see that gear sticking out. You can see the angle piece in here. Oh, maybe got a sleeve in there. So if I stick this piece in here and I put this in here, the final product will be push the button and this sleeve goes down and the thing pops up. So closest I can do to a demo right now is push it in, the button pushes but the gears don't engage, that's why it doesn't work. And if I grab my handy dandy screwdriver and I push this down, you can see that this was just released. Okay, so we'll do the assembly now to the closest thing to the final product. So again, I need to release this. And you're clicking. When I push this in, the ball comes down, and because the things are broken, it's off center, but that's fine. And then when I do the same thing as I did the last time, which is push this down, you can see it just releases itself. So click in, release, click in, release. So the resistance is still pretty high, and there's some, making it bigger is gonna make it easier, and also I can actually double up on all the gears, double up on all the sizes and everything else. So, work in progress.